Somewhere on the far edge of the moon, right around dawn this morning, a scar appeared on its surface that was not there because there is no atmosphere on the moon to carry sound. No shockwave rolling across the dust, nothing but a sudden violent flash of energy and a spray of rock and dust thrown into the black sky. And here's the strange part. This was not an asteroid. It was not a comet fragment. It was us. A piece of human-made hardware just slammed into the moon at more than 5,000 miles an hour, and scientists have been tracking it for months, watching it fall toward this exact moment with almost eerie precision. The object responsible for this is officially cataloged as 2025 Neuro 10D, and its story starts a lot more heroically than it ends. This was the spent upper stage of a SpaceX Falcon 9 Firefly Aerospace's Blue Ghost Mission 1 back in January of 2025. Blue Ghost went on to make history, successfully landing in Mare Crisium on the moon in March of that year and operating a suite of NASA science instruments right there on the lunar surface. But once that upper stage finished its job of delivering the lander, it did not simply disappear or burn up. It kept drifting, caught in a wide looping orbit through the space between Earth and the moon, essentially a piece of abandoned machinery quietly circling out there for over a year. Astronomers did not lose track of it either. A researcher named Bill Gray, who runs a project specifically built to monitor high-orbiting space objects, observed this exact piece of debris more than 1,000 separate times, slowly refining its predicted path with each new observation. And that path led to one increasingly certain outcome. This rocket stage was going to hit the moon, and astronomers could calculate almost the exact second it would happen. The latest tracking placed the impact at approximately 6:35 in the morning Universal Time today, striking near a lunar crater named Einstein, close to the moon's western edge as seen from Earth. On the sunlit side of the near side, we can actually observe. Let that sink in for a second. Scientists on Earth were able to predict, down to the second, exactly when and where a piece of space junk would crash into another world. That is the kind of precision that used to belong entirely to science fiction, and now it is something amateur astronomers with backyard telescopes were actually trying to capture on camera this morning. If stories about real, unfolding space events like this get you hooked, go ahead and smash that like button. It genuinely helps this video reach more people who love space, as much as you clearly do. So, what would this impact have actually looked like if you happened to be watching at exactly the right moment with the right equipment? Unlike a fast-moving meteoroid slamming into the moon, which can hit at incredible velocities and produce a bright, dramatic flash, this rocket stage was moving relatively slowly in impact terms, striking at somewhere around 2.5 kilometers per second. That means less of the impact's energy converts into visible light, and the flash itself would likely have been faint and difficult to catch, even for dedicated observatories. But researchers modeling this event predicted something potentially more visible than the flash itself, an ejecta plume, essentially a curtain of lunar dust and rock violently thrown upward from the new crater. Simulations from a team at the University of Texas at Austin suggested this plume could form a curtain reaching roughly 15 to 20 kilometers high, with a central spike of debris potentially rising as much as 75 to 100 kilometers above the lunar surface. If the models held up, that plume may have briefly caught sunlight and become visible against the blackness of space for a few precious minutes, right at the edge of the moon's bright sunlit limb. For skywatchers in eastern North America, the timing actually worked out reasonably well, since it happened during nighttime hours with the moon sitting comfortably above the horizon. But actually capturing this event was never going to be easy. Astronomers advised that anyone hoping to catch it on camera would need a fairly serious telescope, somewhere in the 6 to 8 inch range, paired with significant magnification and a sensitive camera trained on the lunar limb well before and after the predicted impact time. Most casual observers watching from their backyard almost certainly did not see anything obvious happen in real time. This was never going to be a dramatic, naked eye spectacle. It was always going to be a subtle, scientifically interesting event, best captured by advanced amateur astronomers and dedicated observatories with the right instruments already pointed in exactly the right direction. Here is where the story becomes genuinely fascinating instead of just a curious footnote about space junk. This is not the first time something like this has happened, and it will not be the last. Back in 2009, NASA deliberately crashed a spent rocket stage into the moon's south polar region as part of a mission called LCROSS, specifically designed to kick up material from a permanently shadowed crater and study what came flying out. That mission helped strengthen the evidence that water ice exists, tucked away in some of the moon's coldest, darkest corners, a discovery with enormous implications for future human exploration and potential lunar bases. Then, in 2022, NASA's Lunar Reconnaissance Orbiter spotted the aftermath of another accidental rocket body impact near a different lunar crater called Hertzsprung. That crash left behind something genuinely strange, a double crater, roughly 28 meters wide, an unusual shape scientists are still working to fully explain, which brings us to today's impact and the questions it leaves behind. If NASA's Lunar Reconnaissance Orbiter is able to swing over and photograph this new impact site near the crater Einstein, scientists could get an incredibly valuable before and after comparison, watching a fresh scar appear on the moon in close to real time. That kind of data helps researchers understand exactly how modern spacecraft hardware behaves when it eventually meets the lunar surface, which is becoming an increasingly important question as more and more missions head toward the moon. And that is really the bigger, slightly unsettling story hiding underneath this single rocket stage crash. We are entering a genuinely new era of lunar traffic. Commercial landers, government missions, relay satellites, orbiters, and eventually crewed missions carrying actual astronauts are all becoming part of a rapidly growing flow of activity between Earth and the moon. Scientists have a specific term for the region of space surrounding our nearest neighbor. It's lunar space. And that space is getting busier by the year. Just like roads, shipping lanes, and airspace here on Earth eventually needed traffic rules to keep. Everything from colliding, the Earth-Moon environment is going to need something similar sooner rather than later. Rocket stages and spent spacecraft do not simply vanish once their primary mission ends. Some eventually burn up safely in Earth's atmosphere. Some drift off into a wide orbit around the sun, and some, like this one, end up on a slow, inevitable collision course with the moon itself. If you are enjoying this kind of real, up-to-the-minute space coverage, go ahead and subscribe, because we are covering genuine unfolding events like this one as they happen, without exaggeration and without the fake alien headlines flooding other corners of the internet. There is honestly something a little poetic buried in this particular story too, if you sit with it for a moment. The exact same rocket launch that successfully carried Blue Ghost to a historic, celebrated lunar landing also quietly left behind a discarded piece of hardware that has now become part of the moon's permanent landscape in a much less glamorous way. One mission ended in triumph, gently touching down and operating science instruments on the surface. The other end of that very same launch ended in a violent, silent impact more than a year later, adding one more small crater to a face already covered in billions of years of scars from asteroids, comets, and now, increasingly, our own leftover equipment. It is worth remembering just how much the moon has already been shaped by impacts like this over its entire existence. Every crater visible through even a basic backyard telescope tells the story of some object slamming into that surface at incredible speed, whether that happened 3 billion years ago or earlier this morning. The moon has no atmosphere to burn up incoming debris the way Earth does, and it has no weather or erosion to slowly smooth away the damage afterward. Every impact essentially stays frozen in place forever, a permanent record etched directly into the lunar surface. Today's rocket stage impact simply adds one more entry to that incredibly long, ongoing history, except this particular entry happens to be signed by human engineering rather than by nature. So should anyone actually be worried about incidents like this becoming more common? For this specific event, the honest answer is no. The moon is enormous. The predicted impact site was nowhere near any active lunar hardware or planned mission sites, and the risk to any current or upcoming missions was essentially zero. But the broader trend absolutely deserves attention going forward. As more spacecraft, landers, and eventually crewed missions make their way to the moon in the coming years, the question of what happens to all the leftover hardware trailing behind them is only going to become more relevant, not less. Today's quiet impact near the crater Einstein might end up being remembered less as an isolated curiosity, and more as an early, relatively low-stakes preview of exactly the kind of housekeeping problem humanity is going to need to solve as we keep expanding our presence around the moon. For now, somewhere near the western edge of the lunar disk, there is a brand new crater that did not exist yesterday, created not by the ancient, violent history of the solar system, but by a single piece of our own machinery finally reaching the end of its very long, quiet journey. The moon keeps a permanent record of every single thing that ever hits it, and as of this morning, it is holding on to one more small, quiet story written entirely by us.